Alright, student workbook 22008 freight car brake rigging arrangement. Wabtep Corporation, June 2004. A disclaimer. Part 1, freight car locations. Part 2, freight brake rigging. A, foundation brake rigging. Push rod, brake levers, dead lever guide, truck lever connections, brake rod and pins, brake beams, brake shoes, automatic slack adjusters, brake lever, rod carrier supports, brake bed, plate, truck brake rigging. B, handbrake arrangement, body mounted brake arrangement, truck mounted brake arrangement, bell crank and sheave wheels. C, special brake arrangements. Part 3, brake rigging, adjustment level, angularity, piston travel. Review exercise. Alright, introduction. Understanding the operating of the brake rigging provide with the carman ability to make the repairs will ensure the rigging components function as desired, proper braking force are achieved. There is reduced possibility of personal injury, property damage while working on the equipment. Body mounted and conventional brake rigging on the freight cars uses the body mounted brake cylinder located approximately in the center of the car. The majority of the coal cars, open top hopper cars, and gondolas are equipped with mounted brake assemblies mounted on the end of the car. The design of the brake cylinder is clear. Proximity to the control valve and other brake devices. Each conventional braking arrangement uses the rod levers attached to the underside of the body of the car with the manual type slack adjuster to ensure that there's minimum slack when the brake rigging. The piston travel stayed consistent. The carman inspector had to adjust the rigging from the moving of the manual adjuster on the brake rigging assembly. Conventional rigging today uses automatic self-adjusting slack adjusters to do the same job, manually adjusting the brake rigging. Other car designs are used truck-mounted brake arrangements. Design elements for the lots of rigging necessary conventional rigging by having the brake cylinder attached directly to the truck rigging assembly. In this manual, the various types of brake rigging is covered in showing the relationship of the levers and rods and brake cylinder slack adjusters, hand brakes on the overall operational typical rail car. Alright, freight car locations. Understanding the location of the freight car is basically identifying the repairing item, requiring attention to finding the defects for the car. The basic locations are generally the same on all freight cars. The diagram showing the locations identified with a typical freight car. The end of the car with a handbrake is the B end. The opposite end of the car is the A end. The standing facing the B end, facing the car is the B end facing the car. Everything on the right is the R. The right side, everything on the left is L. The left side, multiple component parts of such wheels, axles numbered consecutively, starting with B end. The cars are divided into quarters using the end and the side location reference of the ARS is A end and the right side, and BL for the B end left side. Brake cylinder is shown on the right side. Alright, your B end has direct axle number 1, brake level left, brake level to the right. B end right, brake level left. First and second, third and fourth. A end and A end brake cylinder center, left side, right side. Conventional brake rigging may have the brake cylinder armed with the car body. In such a case, the brake cylinder piston push rods points to B end, provided with a more direct connection to the handbrake of the brake cylinder rigging assembly. On the cars with more than one handbrake, check the brake cylinder to indicate the B end of the car. Car with multiple handbrakes, brake cylinders generally have locations stenciled on the side of the car. See the AAR Field Manual Rule 83 for more information. Alright, Part 2, freight brake rigging arrangement. The freight brake and the metal components assembled together to transmit the brake application directed to either the handbrake or activation brake cylinder. Brake rigging can be either in the form of the body-mounted brake assembly with the foundation brake rigging and the truck-mounted brake assemblies. A conventional foundation brake rigging. The example of the foundation brake rigging, the various cars may be slightly different depending on the car body design. The main components cover the following page of the same function on all cars. Alright. Shows the rod carrier, lever carrier, AB type controller, the fill of vacuum, the center rod, the emergency auxiliary reservoir, slack adjuster, brake lever badge, brake cylinder, hollow rod, push rod, cylinder lever, slack adjuster, dead lever guide, top rod, brake beams, brake shoes, truck lever connection, bell crank, live lever, 7x14, and handbrake. Alright, the push rod. The brake cylinder push rod is a solid rod with the jaw formed on one end of the brake pin inserted into the jaw end that makes the connection with the brake rigging. The push rod transmits the force caused by the push of the air into the brake cylinder or by pulling the handbrake through leverage the rod to the brake shoe. The push rod is connected to the piston. The push rod ends fit loosely in the tube of the push hole hollow rod. At one more time, the push rods were different lengths. However, most present-day push rods used are 10 by 12 brake cylinders are a standard length of 26.25 inch from the ball end of the center line of the hole of the jaw. The push rod is designed to provide adequate movement to the jaw end without binding with a piston hollow rod. When performing the single car testing, in accordance with the AAR S486, and one of the requirements to make sure that the push rod will go all the way into the hollow rod assembly piston. The check that's done to ensure the movement of the rod's levers is not binding them following. This shows the push rod into the brake cylinder. Alright, 2. The brake lever. The brake lever throughout the brake system and the transmit increase the decreasing brake force. They also use the transfer change over the direction of force levers are named various conditions of the position of the servo of the system. They are body lever that touches the cylinder lever, and the fulcrum lever. They are truck lever that touches the live lever, the dead lever, the horizontal truck lever. The minimum thickness of the levers is 1 inch with a minimum of 1 1/8 of an inch diameter pinholes. Your brake connection rod. The brake connection rods are used to connect the body lever with the truck lever. The center of the top rod of the shown here to the custom next. The two body levers are joint at one end of the braking over the other. Lever rods are connected together with the brake pins in jet. Very important that the connection rod of the pins, the brake rigging, and proper length of the side of them. Proper lengths may be caused binding in the following. Check the car badge plate with the correct length when placing the connection rod where limitation connected the rods according to the AAR Field Manual Rule 11. The AAR designated with the rod diameters must not be less than 3/4 of an inch and pin diameters not less than 1 3/32 of an inch. Alright, this shows your top connection rod hooked up to the brake lever with the brake cylinder push rod and the chain connection to the handbrake. 4. The brake levers are mounted in the part of the brake rigging out of the car body with the part of the truck of the brake. Similar levers are used to transmit the pushing and pulling force exerted with the connection with the rods. Each brake lever is special size is designated to amplify or reduce the brake force determined by the distance between the top end connection to check the badge plate for the proper distance between the holes of each lever. The holes in the lever become elongated to show the excessive wear that they do not provide correct braking force. Check the AAR Field Manual Rule 11 for the wear limits. 5. The dead lever. The dead lever guide with the bracket used to fulcrum one end of the truck. The dead lever of the truck bolster through the car body that provides the anchor for the brake arrangement. Multiple hole dead lever guide is attached to the dead lever bracket. Some of the dead lever brackets may be anchored for the truck of the bill or center sill of the car. With the dead lever guide, always manual adjustment of the brake rigging. One hole end dead lever the guide with attached to the truck bolster. You with the double acting automatic slack adjuster to prevent manual adjustment of the brake. The dead lever to anchor serve the same purpose as the one hole dead lever the guide, with the difference being the dead lever anchor is attached to the car body. Alright, you see the dead lever guide with the holes in it, and then the dead lever bracket, dead lever guide with the brake lever. 6. Truck lever connection. Truck lever connection is sometimes called bottom rods. They are two types of bottom rods. One that passes through the truck bolster, one that passes through the truck under the truck bolster. The person in the rod with the transform the force from the truck lever to the truck dead lever. The truck lever connections are furnished with the various length of 2 3 holes in each end. The purpose of these holes is to provide adjustment required to maintain the good truck lever angularity when different diameters wheels are applied, and 2 wear wheels to machine to one wear tread contour. Shows the truck lever connection. Alright, your brake beams. Your brake beams are used to transfer the force of the truck lever to the brake shoe. They are trussed with the construction with the consistent primarily with the tension compression spring for the attached for the end for the brake hands for the located with the separated with the middle of the truss. At which point with the truck lever attached, the brake beams are designated according to the capacity. For example, the AAR number 24 beam has a 24,000 pound design capacity. The size of the brake of the beam to determine the braking force required for the car. Most brake beams today sliding with the utilized for the brake beam equipped with the extension in each end of the beam. This extension fit is a slot truck slide frame which allow the beam to move the slide at the correct angle with the brake shoe to make the contact with the wheels. There are several types of sliding utilized beams that are designed to specify the applications. Alright, shows the brake beams. The Wabco PAC NYCO pack brake beams are much larger and heavier than the one pictured here. They have brake cylinders mounted on each end. One will Wabtec TMX trucks mounted brake equipment. The brake beams are designed for the center area to bend down. This also allows for the brake cylinder connection rod of automatic. It's like adjuster path in the opening of the bolster. C-section truck mounted with the brake equipment for this manual for the more information. Shows the brake lever mounted. brake beam. Or your brake beam orientation. Brake beams are either left or right-handed according with the angle of direction of the brake lever. The slot with the brake beam strut with the proper lip with the angularity with the braking ring. Determine the correct slot with the direction of the beam and must see sitting on the A or printing top side with the upward top showing with the beam. Standing on the back end of the beam, checking the direction of the slot open to the right hand, to your right hand. On the left hand, the brake beam opens to the right and the right hand beam. Left hand beams are oriented the same way. See the picture below the left hand beam. The brake beams located at each end of the beam are designed to accept and reject either cast metal composition type brake shoe. The brake shoes are set up with rejection and lugs designed to fit the correct with the type brake head, and the car brake configuration will determine the type of the brake shoe standard for the car. Alright, this shows the top lever, shows the TR like line, and the position of the brake beam orientation from the back. Our brake shoes. Brake shoes that transmit the brake force of the wheels that are provided with the retarded motion of the car. The brake shoes that identify the type of the thickness of the proper brake heads. The two general type of the brake shoes: the metal cast iron composition. Cast iron brake shoes were used for the older cars. New cars designed with the composition shoes, high friction composition shoes that approximately twice the stepping ability of the cast metal shoes. For the reason this cast iron brake shoes are not interchangeable with the composition brake shoes as shown below. The brake head designs are used only in one type of the brake shoe. Alright, your cast iron shows the brake shoe and the brake head. The composition shows the difference between slots in the brake shoe. Cast iron brake shoe. The cast iron brake shoe were originally used in the railroad brake equipment. They typically used for the car or for the hanger type brake beam with the body mount with the brake equipment. The AB control valve. They require the higher braking force to stop and slow the car of the locomotive with the high friction composition shoe. Drawback for the cast iron shoes include sparking, uneven wheel wear, and noted the AAR sticker letter C9736 and adds to the AAR Field Manual Rule 12. The application of cast iron brake shoes is prohibited effective January 1st, 2015. Converting with the car for the cast iron with a high friction composition shoe. The brake equipment of the freight car must be adjusted with one of several ways. Change the brake lever, the ratio of the cast iron requires more braking force than high friction. Simply the changing the shoes will result in excessive braking force of the wheel with the brake related to wheel defects. 2. Changing the brake cylinder size. Having a smaller brake cylinder will result in less force of the shoe on wheel provided with the full surface brake application. Equalization pressure remains with the AAR limits. Using modulating valve, the modulating valve will divert some of the air from the brake cylinder to the separate volume. Note that the conversion of the locomotive from the cast high friction composition shoe requires changing a J-type relay valve with a simpler alternative such as low friction composition shoes. Alright, showed in the picture is the modulating valve applied with the brake cylinder. B. Low friction composition. The Cobra LF low friction composition brake shoe is designed with a cost-effective alternative cast iron brake shoes, including introduced in 1997. Low friction shoe was designed for the use of the locomotive equipped with the cast iron shoe direct for the replacement of the cast shoes. The benefit of the LF shoe with the longer life, lighter weight, less maintenance. Low friction composition shoes are also used for the freight equipment. The Cobra LF shoes will fit into the brake heads designed to accept the cast iron brake shoe with the rejection, but the rejection will not permit the shoes to be applied with the brake heads designed with the high friction composition shoe. Everything new with the Cobra LF composition shoe is painted bright yellow. Immediate identification. This will alert all the installers at the time of the replacement should be required even before the older shoe is renewed. The new Cobra LF composition brake shoe has a cast iron insert with the center of the shoe. With this insert, the condition of the wheel tread, thereby reducing potential of the wheel damage. Picture to your right is the Cobra LF composition brake shoe with the insert with the C. Your high friction composition. High friction composition brake shoe with the design with the alternative cast iron brake shoe with the HF composition shoe with the higher the coefficient friction provided with better brake control, less brake head force than cast iron shoe. Cobra AP Advanced Performance High Friction Composition brake shoe was designed to better adjust the curvature of the wheel. The tread guard shoe. Tread damage such as shell spalls and the creative nature expensive with the maintenance of the Cobra. The TG brake shoe with the design to reduce the wheel tread damage. The design with the same with the tamper shoe with the Cobra AP brake shoe with the Cobra TG brake shoes have been added the value of the built into them. The shoes have a metal insert model into the friction material with the center of the shoe, but works in two ways. The first one slightly tightens the tread surface to improve the wheel adhesion, thereby decreasing likelihood with the wheel slides. And second, because of the insert more abrasive at the base of the composition material, it works continuously to remove the minor and tread damage and improve the condition of the tread. The Cobra TG brake shoe with the painted red immediately identification if the change of the brake shoe due wear to ensure that the correct replacement shoe is applied. When removing the tread gear shoe, they should be replaced with the kind of accordance with the car owner's specifications. The tread guard brake shoe also has the decal applied with the inside of the portion of the shoe with the identification. Alright, it shows the Cobra tread guard TG high friction composition brake shoe to your right with the insert. 9. Your automatic slack adjuster. Manual automatic slack adjuster is designed to compensate the slack curve with the wear with the curve with the brake shoe with the wheel with the other component with the brake ring by controlling the slack of the air brake pistons to maintain with the current length to ensure the maximum efficiency with the brake system. Most automatic slack adjusters double jaw the design for the application of the conventional and foundation brake rigging to the mount of the brake from the truck mounted brake assembly. The name difference of the two designs side of the operation body mounted automatic slack adjuster of the foundation brake rigging is designed with the center right at the top of the application body with the mounted slack adjuster. Take up the slack in the components wear down with the truck mount with the slack adjuster. They have the same function, however they operate with the extent of the brake shoe wear down. Truck mounted slack adjusters are also much smaller than the body mounted adjuster. These are attached and played for the bottom rod connection with the truck assembly. Alright, the body mounted slack adjuster. The body mounted slack adjuster operates with the adjustable rod with the automatically shortened with the wear of the curve with the extent with the new brake shoe with the new wheels are applied with the total length of the body mounted slack adjuster fully extended with the 84 inches of the install length of the new car with normally 81 inches. Measured from the center of the pinhole located with the adjuster jaw of the dimension of the area of the car and the side of the corners with the amount of the brake shoe, the wear wheel wear. The group E of the double jaw mounted with the slack adjuster along with their design with the control mechanism are interchangeable with each other. The body mounted the automatic slack adjuster is equipped with the actuator control rod with connected to the body with the slack adjuster control collar with adjusting screw. The actuator control rod is impinged with the top of the right rod end with the cylinder lever and fulcrum of the control lever bracket. The purpose of the control lever is drilled in portion with the cylinder lever. The whole drilling to activate the slack adjuster. It does not transfer or regulate the braking force of the car. The actuator control rod of the collar is moved depending on the piston travel. The adjustment required once the piston travel has been adjusted the correct length of the adjusting screw with the screw to ensure the adjustment does not change the collar of the actuator control rod must be welded in place in accordance with the AR Field Manual Rule Number 4. Shows the slack adjuster actuating control rod with the control collar adjusting screw and also the universal model 2300 DJ body mounted. Alright, B, truck mounted adjuster. The truck mounted slack adjuster work opposite a body with the mounted slack adjuster with the brake shoe with the wear down because of the location of the truck assembly. Slack adjuster gear is longer to maintain the correct slack through the use of the actuator control with the control lever to achieve the following types. Universal model FD, the use of the throttle David the truck mounted brake assembly has the 5-inch let capacity as the replacement of the Model 7D. Your Universal 85 AR approved to use to upgrade with the WAPCO PAC truck mounted the brake arrangement of the WAPCO PAC 22 8.5 inch let out capacity. Universal model 85, Universal model 5. Use the TTX truck mounted brake assembly with 5-inch let out capacity replacement for the Model 7. The jaws painted orange for the identification. And here's your Model 5. Alright. Universal Model C1000 AR approved with the TMX truck mounted with the brake system 9 3/4 inch let out capacity. Your Universal Model C1000 is shown just below that. Note that the Model F and FD with the Model C1000s are equipped with the trigger pin and locking bolt assembly designed to prevent slack adjusting extension until the universal compression slacker is properly installed. The trigger and pin locking bolt shown here. 10. The brake lever and the rod carrier support. The brake lever and rod carrier supports are applied with the car with the various locations to support the lever and rod, respective of the position and point of the stress inside of the location of the carriers because of the movement of the lever, the brakes applied with the release and shoe with the wheelchair, where changes the carrier should be given the application of these car carriers to prevent any binding with the braking rigging. Part 11, the brake badge plate. The brake badge plate with the metal plate with the design to provide with the brake rigging dimension that may not be readily available. The information of the badge plate may include with the brake lever the drilling dimension, the handbrake, the chain length of the brake, piston travel, the length of the top of the connection rod, the bottom of the connection rod to the length of the accessory of the badge plate, especially useful to prepare the brake rigging or to verify the correction piston with the check proper level dimension. The badge plate is generally located near the brake cylinder and the control valves. 12. The truck brake rig. The freight car truck is not only supported with the car, but also must assist the stopping the holding of the car from the through you for the air brake and the handbrake force is exerted with the brake shoe for the wheel for the freight car truck for the design for the truck level arrangement. Truck mounted brakes on the level of the arrangement generally even the level of the components provided with the same braking effectiveness of the body mounted brakes. Alright, your part 3, your handbrake arrangement. Body mounted brake. Your body, the show is over here. The handbrake is applied to the box car. You have the handbrake wheel and the bell crank. Your body mounted brake equipment head at the bottom of the connection rod running with the opening the bolster onto the bottom rod under the truck bolster. The picture below shows the rough of the three-rolled design. Note the truck lever to come extremely passing through the truck bolster is pinned with the center hole of each of the truck lever, the bottom hole of the truck lever, and pinned to the brake beam. The top of the rod will be pinned to the top of the live lever. Most of the pass over the truck bolster to connect with the body lever. The top end of the dead lever is usually fulcrum to the truck bolster and the dead lever guide. The truck lever usually has a 2-to-1 ratio of the same. So force exerted with the brake shoe are twice the top of the rod force. Conversely, the top of the rod movement is 4 times the movement over the brake beam. When the handbrake is applied with the lever to the rod, moving in the direction relationship with the movement of the body lever is connected with the piston push rod in this way the brake shoes are forced against the wheel. The application with the brake, whether the application is directed with the handbrake or the force of the brake cylinder piston shown with the diagram handbrake note. The dead lever bracket guide are used in the anchor to maintain the correct force applied at the shoes. Alright, shows the handbrake with the chain, the dead lever, your brake lever, your brake shoes, your live lever and dead lever, your braking chain, your fulcrum lever, dead lever and back lever. Our truck assembly with the bottom connection rod under the truck bolster function in the similar manner with a couple of extensions and expectation the bottom of the connection rod being under the bolster is pinned at the bottom hole of each for the truck lever. The center hole of the truck lever is connected with the brake beam. The top of the lever the holes are top of the connection rod, rod to the dead lever. The AA Rule 11 provided the inspection where of the limitation of the type of the connection. 2. Truck mounted handbrake arrangement. The operation truck mounted handbrake assembly is similar to the body mounted handbrake arrangement, except for the left component of the diagram below. The typical Wabco PAC with the noted that the handbrake is connected with the brake beam. Through the lever, the connection rod will ensure that they are direct braking application similar to provide with the air activated brakes on the new truck mounted with the brake equipment change with the car design result of the more type of the trucks mounted with the brake assembly available. Some of the common type of the truck mounted handbrake arrangements are the Cardell Wabco TMX LCon National TBMB Thralls Davis TMB, the TTX TMB, or the NYAB has been several types available. Each of these designs have the brake cylinder mounted with the brake beam and applied directly to the truck bolster. Cylinder force is directly on the brake beams without intermediate leverage. The rod push of the brake shoe against the wheel. Force exerted of the brake shoe are actually output for the forces of the cylinder. Each type of the truck mounted arrangement is discussed in the single car textbook booklet Wabco SCT 1 and 2. Alright, shows the Wabco shown here with the 2 brakes on the per truck with the 1966 became mandatory requirement to apply automatic slack adjuster on all new cars. 1968 with this all applied with the rebuilt the cars. However, still many cars are equipped with the Wabco pack and the NYCPA truck mounted brake system. The handbrake wheel, the different brake shoes with the connection rod, the piston pins. Bell cranks and sheep wheels. Handbrake is designed to provide with the brake shoe for the shoes again for the wheel and direct pull with the rod lever with the truck. Some with the bell crank with the common older style with a lot of new cars with the use of the sheep wheels and both capable to use the change for the vertical pull with the handbrake to horizontal pull with the rigging. When performing the single car test per AA or S486, the carman must check for the position of the bell crank with the brake is applied with the brake. This size because of the bell crank that has been in fixed position. When the handbrake is applied with the pull, the handbrake will cover the fulcrum handbrake to rise the potential pulling horizontal chain. If the brake rises too high, there will be not enough force for the shoe to hold the car in position on the cars with the automatic slack adjuster. The shoe wear down below the bell crank and stay in the correct position on the cars with the automatic slack adjuster. Wabco's BAC and the NYCPA PAC brake shoes were down with the position bell crank of the design. The inspector must be considered with the check in the position of the bell crank during the air test. Usually either device depends on the design of the car. Both handbrake designs show the previous page for the bell crank sheep wheels to extensively carrying the intermodule automobile traffic. 4. Special brake arrangements. Brake arrangements. Specialized cars that depress the center flat cars. The other cars that have high capacity have more than they have the trucks equipped with a 6 to 8 to 10 to 12 wheel slab. The cars also may have more than one hand brake, typically on each end of the brake arrangement. Each of the cars according to the brake shoe force applied applicable to the car design. The car weight of the rail of the braking arrangement will normally employ the items identified in this booklet. Alright, here is a bell crank. Alright, this is your sheave wheel. Alright, part 4, foundational brake rigging and adjustments. To ensure the braking force exerted with the shoe against the wheel, the brake rigging must be in good condition applied with the correct weight of the car. Where operative applications damage the brake rigging, the component of the detrimental effect of the braking efficiency must be corrected to ensure adequate braking of the car for that car. Even though most cars are not equipped with the automatic select adjustment, the track levers may occasionally be adjusted. The section of the booklet is able with the sub adjustment that may be made with the model of the brake rigging to ensure the brake force is sufficient to effectively stop the car before performing any adjustment of the brake ring. Ensure that the car brakes are relief that there is no air brake system. This is done to prevent unintentional braking application while someone is working with the brake equipment. 1. Your leveler angularity. Angularity of the angular relationship with the lever of the brake ring. Assembly and the angularity of the car. The brake ring is incorrect with the rod levers may be blinded foul on other than the car. The brake ring components. The condition will be provided in effect with the brake forcing of that car. Truck lever angularity. Truck lever angularity change with the brake when the brake shoe of the wheels wear of the automatic select adjuster will compensate for the wear of the shoe of the wheels in the normal application. With the wheels are changed and may effectively level angularity. With these are common. The bracket of the brake lever angularity should be checked each of the time the wheels are changed. For this reason, the lever angularity could be different on each of the truck of the same car. Correct truck lever angularity is when the live truck lever is perpendicular with the top of the rod when the brake is fully applied. Application of new wheels, brake shoes, improper application, brake rigging components, wearing rigging components can cause the board truck level angularity. The truck level angularity is incorrect. The adjustment should be made to maintain the correct brake shoe pressure on the wheel for each of the brake applications. The correct truck lever angularity. Alright. Alright, the common location of the adjustment of the truck level angularity with the bottom around the truck lever, the connection about with the rods have more than one set of holes at the end each of the rod. Each of the brake shoes that are worn with the beyond the AR limit should be changed before making the adjustment of the truck lever and the rod connection. The lever guide can also be provided with location level of the angularity. Adjusting correctly incorrect truck level angularity shown below. Cut out the car air brake, disconnect with the brake rigging, automatic slack adjustment with the manual slack adjuster, remove the brake pin with the bottom rod lever the connection. 4. Move the live lever to the line up at the bottom of the red next to the outside hole. Apply the brake pin. Physically move the lever hand to apply the shoe with the wheel check adjustment. If the level angularity requires more, must adjustment repeat steps 4 through 5 and 6 until the correct angularity is obtained. 8. Movement of the bottom rod must not be set up in a situation where the lever rests on the axle. If there happens, adjustment of the dead lever guide may be necessary. Not the movement of the dead lever has been a dramatic effect of the live lever movement of the bottom rod connection. Poor truck lever angularity. Alright. Your brake lever, body lever angularity. The movement of the truck levers will affect with the body level angularity of the cars equipped with the brake rod lever. The properly correct truck level angularity with the correct body level angularity. The correct body level angularity which whenever there's a perpendicular to the brake rods when the brake shoes and wheels are worn halfway. Correct body level angularity. Alright, and incorrect brake rod lever the links will produce incorrect body level angularity. Okay, incorrect body level angularity. If the body level angularity is incorrect, first measure the level of the rods and ensure the measurement of the rod and level that correspond with the badge plate dimension. If the that measure the badge plate correct with the action necessary before changing the angularity with the correct truck level angularity to correct the body level dimension, body level angularity can only be adjusted by changing the rod length. 2. Piston travel the distance between the brake cylinder and piston. Move the brake release position to the brake applied position. On the various type of the brake cylinder, each with the design with specific piston travel allow the design to provide the maximum braking force with control to stop the particular car body with the amount of the brake cylinder design is by size is 10 by 12 the brake cylinder and it's a 10 diameter and a 12-inch stroke. Brake release, brake applied. All right. Position travel to the standard body amount of the brake cylinder is initial with a set 8-inch for the equalization purpose of the per AAR S401. Piston travel must set with the proper length in accordance with the AAR S486 before cars allowed into serve the piston travel amount of the body braking arrangement. Braking ring automatic slack adjuster normally set with the 7.5 inches. When testing the cars in accordance with the AAR S486 allow piston travel to the type of the brake cylinder in the 7 to 9 inches. The piston travel less than 7 inches more than 9 inches must be adjusted to the nominal 7.5 inches. inches. Piston travel of the standard body mounted to the brake cylinder is measured for the face of the brake cylinder with the down pressure for the grease line, with the head of the grease line near the piston collar, with the grease line has been established by the AR measuring point of the brake cylinder piston shown. Measuring the piston shown. The non-pressure head of the piston grease line, piston travel between the non-pressure head and the grease line. Alright. Or piston travel other than the type of the brake cylinders identified with the AR Field Manual Rule 3. Brake cylinder mounted body 10 by 27.5, 1/4 inch plus or minus 6 or 9 inches air test allowance, 10.5 and 10.5 inches maximum travel. The body mounted 8.5 by 12 inch, 7.5 inch proper 1/4 plus or minus 1/4 inch, 6 to 9 inches air allowance, air test allowance, 10.5 inch maximum travel. Body mounted 7.5 by 12 inches proper travel to 7.5, 1/4 inch, 7 to 9 inches air allowance, 10.5 maximum travel. Your body mount 12 by 10 with the 5.5 inch proper level to 1 plus or minus 1/4 inch. 5 to 7 air allowance, and 8.5 is in your maximum travel. 7/5 of an inch by 12 by 9 inch UC. 5.5 inch proper length, 1/4 inch plus or minus 5 or 6 inches air allowance test and maximum travel 7.5. The Tri-X 2, 1/3 inch piston proper travel with 1/8 of an inch plus or minus 1.5 to 3 inches air test allowance, 3 1/4 inch maximum travel. Alright, the WAPCO PAC NYC PAC, the proper travel is 1 1/4 inch plus or minus 1/4 inch. The air allowance test is 3/4 inch to 3 inches. The maximum travel 4 inches. The WAPCO PAC 2.25 inch proper travel 1/4 inch plus or minus 1 3/4 inch to 3 inches. Air allowance 3 1/4 inch maximum travel. WAPCO TMX 2 inch proper travel 1 1/4 inch minimum plus or minus 1.5 inch to 3 inches. Air allowance test 3 1/4 inches maximum travel. The NYPCA 2A not applicable, maximum travel 2 1/4 inches. Electron National 2 3/4 inch, proper travel plus or minus 1 1/4 inch, 2 1/4 inch, 3 by 2, 3 3/4 inch, air allowance test, maximum travel 4 inches. Through all David 3 1/4 inch, proper travel to 1 plus or minus 1/4 inch, air allowance test 2 3/4 inch to 4 1/4 inch, maximum travel 4.5 inches. The TXDMB Minister 8 inches. Proper travel 1/8 of an inch plus or minus 7.5 to 10 inches. Air allowance test and 10 1/4 and maximum travel. Alright, the AR design with the top connection rod must be in the minimum. The handbrake end of the car is generally designed as the body slack adjuster. Generally use the end blanket to maintain a proper piston travel. The brake lad dimension may be found on blanket, which is usually located on the close to the brake valve. The blanket universal are equipped with the trigger pin locking belt and for safety. Alright, the truck mounted brake equipment, the safety procedure with the warning. And part 4, truck mounted brake equipment. We're going to read this chapter tomorrow.